In the following exercises, use the properties of logarithms to condense the logarithm, simplify if possible. So here we're going to condense. Condense simply means get it down to a single log. That's what the condensing means. So for us, in this one here, since there's an addition between the logs, that means I'm going to multiply them. So that means I would get the log base, 4 times 25 is 100. And there's another thing to realize here, that when I don't see a base under my log, it's understood to be 10. Now I'm just going to write this another way. I'm going to put the 10 in there. This is really 10 squared is 100. And those can cancel, and I would just get 2. Now again, I'm using that idea of inverses like I talked about in the last video. So that equaling 2 makes it much more immediate if you get comfortable with those ideas. Try to if you can. Okay, now for the next one here. This one here is we have these algebraic expressions here, and I also have a coefficient in front of my log. So what I'm going to do here is I'm going to use my power rule first. So I'm going to put that to the inside. And let's see how that works here. So I'm going to write 273 down here. So this is going to be log of x squared plus 2x plus 1 minus log base 10. And then in parentheses, I'm going to use a bracket first, and I'm going to go x plus 1, because it's got to square everything in there. And I don't know if you know this or not, but this is really log of x squared plus 2x plus 1 minus log of x squared plus 2x plus 1. Oh, I ran out of room. Plus 1. And they turn out to be this, so you would think it would be 0. Right? Because I get the same thing minus the same thing. But let's say you didn't catch that. And with the minus of logs, I'm dealing with a quotient rule. So this is really the log of x squared plus 2x plus 1 over x squared plus 2x plus 1. And that's really the log of 1. And if you didn't know the log of 1 was 0, I would have to say, okay, let's take the log of 1 equals y. And I'm going to put my 10 down here so I remember what my base is. That's 10 to the y equals 1. So what does y have to be here to get 10 to that number equaling 1? It would have to be 0. So that's why we get 0. So the log of 1 is always going to be 0 there. So let's take a look at 274 now. Okay, so I'm just going to do all my powers first. So that's going to be log base 10 of x to the 4th minus log base y squared, or log base 10 of y squared, minus log base 10 of z cubed. And that's my first step. Now notice those are all minuses there for the most part, except for the first one. So you may want to do 2 at a time, just because that may be confusing to you. So for this first 2, if I put those together, I'm going to get log base 10 of x to the 4th over y squared. Now keep in mind here, in order to put those together from addition subtraction, remember my logs have to have the same base. If they have different bases, I can't do this. Okay, so this is log of z cubed. So now that's a division of those two. So then my final answer for these is going to be y squared z squared. So this is the answer for that last one. So it ends up on the bottom along with the y. Now one way I think of this is I think of these as an exponent of -1. So it's going to flip it to the bottom. So anytime I have a negative on my log, that's why I think that it's like a 1 there. So it's like a -1. So it's automatically going to put it on the bottom. So just something to think about too. That helps me with these. All right, so there you go.